Okay, fine. So we'll be getting into it. So in Unit 2, we have been covering with respect to your breakdowns. Okay. So dielectric breakdowns we have been seeing. So in the dielectric breakdowns, we have been classifying them based upon the medium in which the breakdown has been occurred. Okay. So based upon that, the medium in which it occurs is first it is starting with your gaseous medium, followed by the vacuum medium. After that, liquid breakdown. It is the liquid medium. And today we will be moving out with your solid breakdown. So the last class we might have gone through the liquid breakdown. So today's class we will be going through the solid breakdown. Okay. So in the solid breakdown, there are different types of breakdown mechanisms. So what are those mechanisms if we are seeing means? What are those different kinds of breakdown mechanisms we are seeing means? First one is intrinsic or ionic breakdown. Second one is electromechanical breakdown. Third one is failure due to treeing and tracking. Okay, failure due to treeing and tracking. So this third subdivision is very, very important. So fourth one is thermal breakdown. Fifth one is electrochemical breakdown, chemical breakdown, and the last one will be breakdown due to internal discharges. So this is what you'll be seeing in today's lecture. So today's lecture will be a little bit of a lengthy one, but it will, the concepts will be very, very simple. What you have already seen. So breakdown in solid dielectrics. So you have to know why, what is the need to break the dielectric strength in your solid medium. Okay. So why it is needed means to insulate one current carrying part from another when they operate at different voltages. Okay. So solid dielectrics have different breakdown strength. Okay. That is the breakdown strength is very higher. So why I am saying this means so we can move the time, then you can understand. So now you already know that in your liquid or your gases, okay, so take this and you take a gas. So take this gas. So in your gas, as you can see, your how your atoms should be arranged. Okay, for a gaseous molecule or a gaseous substance, if you are taking means how the atoms should be arranged. Means they'll be very very loosely packed. Okay, it might be very very loosely packed. So this one might be over n more than 10 meters. So like that, the distance between each atom will be very very large. So the same thing now, if you are moving to a liquid, you're moving to a liquid. So in your liquid, how it will be means it is somewhat loosely packed. So the distance between the two atoms will be somewhat loosely packed. So in this fashion, so this is how your liquid. So this is your liquid. Okay. So now coming back to your solid. Okay. So we'll be seeing about solid over here. So in your solid, how does your atoms will be? Atoms will be very, 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 very closely packed. Okay. So like this fashion, it will be in a very airtight or a very tight manner. Okay. So this will be your solid structure. So this will be your solid structure. So now what you have to see means you are applying a electric field. You are applying an electric field. You are applying an electric field over here. So positive, negative. So you are applying an electric field. So in general, uh, the tendency to conduct is occurs. That is, the tendency is to conduct will be very high. That is, the breakdown will be occurring very fastly in your gas. Okay, the possibility for so can you hear me? I'm audible, right? I'm audible, right?
Yes, sir. Yes, sir. Audible, sir.
Okay, okay, fine. So I just got was just interrupted. So okay, moving on. So if you're applying the electric field over here means, so dielectric breakdown means it's the ability to conduct in the medium. Okay, by breaking the dielectric strength. So if you are comparing means, first the gas medium will be breaking down very easy. Okay, because the atoms are very loosely packed over here. Okay, so second, followed by your liquid. So in a liquid medium, so it will be very it will be also loosely packed. So the speed of breakdown will be higher. Okay, but in your gas it will be very very high. But when you're coming back to the solids, so what happens is that they are already very very closely packed. Okay, so in order to make conduction, what you have to do is you have to break the bond between these two atoms. Okay, so which is a very tedious task, and you need a very heavy amount of energy to break this. Okay, so that's what they are saying over here. That is, solid dielectrics have a very high dielectric breakdown strength. Okay, yeah, we having a very high dielectric breakdown strength when compared to the other medium. Okay, when you are comparing to the other medium, it will be having a very high dielectric strength. Okay. So moving on, the properties of good dielectrics. So how a good solid dielectric should be. Okay. So first one is low dielectric loss, high mechanical strength. That is, they are saying the dielectric means nothing but an insulator. How a good insulator it must. So how it must be means it must have a high mechanical strength. So it must be free from gases or moisture. You already know what you see in cathode and anode heating. So you just recall it. So in that, due to the moisture content on the surface itself, there might be heating over the cathode and the anode. Be resistant from thermal and chemical deterioration. So we'll be coming to the breakdown mechanism. So what are the breakdown mechanism means? First one is your intrinsic or ionic breakdown, followed by electromechanical, the same thing, what we have seen in the beginning. Okay. So here they have given out a graph. They have given out a graph. So what this graph indicates is that it is nothing but the graph within your breakdown strength across your time. This is a time, but the scale it is given in the log scale. Okay. So log scale means similar to your body. Okay. So what you can see is within a very short duration. Okay, so these mechanisms, which will be happening very quickly, means first it goes to your intrinsic and your electromechanical breakdown. Okay, so next is your streamer. So here streamer is similar to the streamer what you have already seen in your gas years. Okay, so this streamer comes into the category of clean and track. Okay, so after that only thermal, and finally it will be your chemical reaction. Breakdown. Okay. So we'll be getting into the first part, intrinsic breakdown. So what is intrinsic breakdown? So it depends upon the presence of free electrons which are capable of migration through the lattice of the dielectric. So lattice is nothing but the you can for your Understanding? You can just keep it as a valence electron or a valence shell. So lattice consists a valence shell. So if there is a presence of free electron in the valence shell, means there is a still more possibility to conduct the breakdown. That is, the breakdown will be very easier. Yeah, the probability of the breakdown to occur will be very much higher if there is free electrons. Okay? So usually a small number of conduction electrons are present in solid dielectrics along with some structural imperfections. So there will be some kind of free electrons in the solid particles or solid medium. Why it will be there? Means due to the structural imperfection, there will be by default the impurity. Okay. The impurity atoms or molecules are both act as traps for the conduction. So these impurity atoms are uh, particles which are responsible for your conduction. So when these ranges are exceeded, additional electrons is added to trap the electrons. So these two processes you already know. Based upon this, there are two mechanisms: electronic breakdown and avalanche or streamer breakdown. So electronic breakdown. So intrinsic breakdown occurs in time. So here, if I each breakdown mechanism, there's a time period. So as I said, we have seen in the log time period graph. As you can see here, it will be the take very minimum time duration for conduction. It is for the breakdown process to occur. So here you can see, right? So this value will be in the range of 10 power minus 8. It will be in the range of 10 power minus 8. Okay. So the initial density of conduction electrons is also assumed to be large. Over here, the initial density, that is the number of electrons formed due to the breakdown, is very high. Okay. So that's what they're saying. When an electric field is applied, electrons gain energy from electric field and cross the forbidden energy, forming forbidden energy from the valence band to conduction band. This concept I have already told in your gaseous breakdown. So when you're moving from your valence band to your conduction band, there will be some amount of energy liberated. So next is coming out as your avalanche streamer breakdown. So this is similar to the gases, breakdown in gases due to cumulative ionization. So an electron within the dielectric starting from the cathode will drift towards the anode, okay, and during this motion gain some energy from the field and loses it during the collision. This is similar to your breakdown which is occurring as you have seen here, avalanche breakdown. This might have you have studied in your electron devices subject. Okay? So it is nothing but an breakdown which occurs due to the field, due to the presence of field. Okay, so there might be some free electrons. Okay, so for example, they have this. So over here you can see here. So what they are saying is that an electron within the dielectric starting from cathode will drift towards the anode. During this motion, gains energy from the field and loses it during collision. So this is the first part. Okay, this is the first part you have to take. Okay, so we'll be erasing it. Yeah. So now if you are seeing is take a solid medium. This is a solid medium. So you are applying a cathode and then you are, okay. So now what happens is that when you are applying this thing, so normally an electron will be forming and it will be moving towards your anode. Okay. So this is your cathode. So it will be moving towards your anode. At the time of moving from here to here, there will this electron will be possessing some amount of energy. Okay, this electron will be possessing some amount of energy. So this energy is what it causes to move towards this anode. At the time of moving, what happens is that if it is abstracted by some kind of obstacle, like another one electron means, the energy will be supplied to this electron. Okay? Energy will be moving towards this electron. Okay, so that's what we have to see through. So when the energy gained by an electron exceeds the lattice ionization potential, an additional electron will be liberated. So if it is a electron, its charge means no problem. If it is a molecule in the sense, what happens is that this molecule or atom will be splitting out into two, similar to your nuclear fission. Okay, this will be splitting into two electrons, two more electrons. Okay, so like that, this goes on. This process repeats itself, resulting in formation of electron avalanche. So this is how it looks like. First at this point it starts, then it moves on, then it moves on, and finally it forms like a stream, okay? Stream of structure. So this above this you can take it as a cathode, and below this you can take it as an anode. Okay. So like this it just travels. Okay. So next breakdown is your electromechanical breakdown. So electromechanical breakdown is nothing but when solid dielectrics are subjected to very high electric field, okay, the failure occurs due to electrostatic compressive force. So here what happens is that you're applying a very high electric field in your solid, your dielectric, a solid medium. Then what happens is that due to the compressive forces will be due to your, it's a kind of a mechanical force. Okay. Electromechanical force means, breakdown means, it is a thing which is passed by your electrical field. Oh, and that is your electrical field will cause a mechanical force. Okay. The electrical field will cause a mechanical force to cause a break. So here your mechanical strengths will be coming. So in smallness you have to take. So this is a formula they have given. Okay. See, a compressive force will be acting over the medium, and that compressive force depends upon your electric field. Okay. So that's the formula here they have given over here. Okay. It's a formula they have given over here. So moving on to your thermal breakdown. The thermal breakdown you already know, as the name suggests, so due to the excessive amount of heating over the solid medium, okay, so the breakdown will be initiated. So that's what they say. In general, the breakdown voltage of a solid dielectric should increase with its thickness. Okay? But this is true only up to certain thickness. So the breakdown voltage depends upon the thickness of your solid dielectric medium. Okay? So above this thickness, that is, you can take a threshold value. The heat generated in the dielectric due to flow of current determines the conduction. So what they're saying is that when an electric field is applied to the dielectric, we are applying an electric field to the dielectric, conduction current, however, small it may be, the conduction current may be very small, okay, the flow through the material. But this very small amount of current will be heating the specimen. Similar to the current conduction in your electrical. So surely in practical case, always your line will be having I square R loss. So your I square R loss is one which will be contributing for your heating of the line. Okay, similar to that. So here they have given the heat generated due to the stress. Okay, they are given. So sigma is the DC conductivity of the specimen. Okay. So this is the energy, okay, watts per centimeter cube. So it is, if the same thing is happening in your AC field means you have to go on with this formula. So where del is your loss angle of the dielectric heat. So this is the main formula you have to get into. Okay, so thermal breakdown is a very important question. They will be asking frequently. This is what you have to get into. So this is the formula for the thermal breakdown. That is, the heat dissipated WT is equal to CV. CV is nothing but the specific heat of a specimen. For each and every type of material or type of the atom, there is a specific heat value. Okay. So this specific heat value you can see it in a logbook table. So the logbook table you can see that. So your T is the temperature of the specimen. K is this is a normal kind of. Okay. So what we'll be saying is equilibrium is reached when the heat generated becomes equal to the heat dissipated. So this is a very, very important concept. This one you have studied in your chemistry. So, so as a law, as a particular law you have studied. I think it is a law of section 1. So this can't recall it, but it is this refers to a particular law in the chemistry that you have already studied. That is equilibrium. Equilibrium is nothing but a stable state. Okay, so stable state is reached. How it is reached when the input what it is given to be equal to the output. Okay? That's what this is. The heat generated becomes equal to the heat dissipated. So this is a normal condition. Between WT, the energy for the breakdown, WAC energy in your AC or WTC. So next we'll be going through the chemical or electrochemical deterioration. Okay. So you know some of the chemical actions, you know. So due to some of the chemical actions, there may be some kind of breakdown. So this oxidation. So oxidation, in presence of air or oxygen, it is such as rubber or polyethylene oxidation, giving rise to surface. This is similar to the rusting of. Okay. So in case second hydrolysis. So this is some chemical actions. This you can just read it down. So next is a very important concept, breakdown due to treeing and cracking. So also a very important concept. You have to see through this. So that is when a solid dielectric is subjected to electricity. It's nothing but you're applying an electric field only. For a long time. Okay. Normally, two kinds of visible markings are observed. That is, the observation will be of two kinds. So first one is the presence of conducting path across the surface of the insulation. So there might be some conduction path over the surface. Second one, a mechanism whereby leakage current passes through the conducting path. So this leakage current will be responsible for formation of a spark. So there might be, due to this spark, the insulation might degrade, and this might causes the breakdown. So the spreading of spark channels from two electrodes is called cracking. Okay. So that is the first one. The presence of conducting path across the surface, which will be leading to the cracking. Okay. The formation of branches is called tree. This I can show you in the diagram. So this is the example. Okay. So consider a system of solid dielectric having a conduction film and two electrodes are there. in the practice, the conducting film very often is damaged due to the moisture. This you already know. Due to the if there is a presence of moisture over the surface of the dielectric medium, so then it will be favoring you a breakdown. Okay. So on application of voltage, okay, you are applying the voltage. The film starts conducting, resulting in generation of heat, and the surface becomes dry. Okay. So if there's a moisture over the surface means, okay, you're applying the electric field, and which causes the heat to make the wet surface to become a dry one. Okay. The conducting film becomes separate due to drying, and so sparks are done, damaging the dielectric surface. So this process leads to insulation failure. So they have given out a voltage, that is dielectric voltage. Usually tracking occurs even at a very low voltage for 100 volt. Okay. It depends upon in which material you are, but the treeing or the branches which is coming from the stream will be for your high voltage. So this is a normal definition you can just go through. So where you can find this treeing phenomenon is the cables. So next is the breaking due to internal discharge. So how this internal discharge occurs is due to the presence or possibility in your cavities or valves within the medium or at the boundaries. So if there is any kind of void or any hole, okay, in the medium or at the boundaries between the things, what happens is due to these voids, the dielectric will be. So this is the formula for the same formula. Previous slide. Okay, over here the main important question they might be asking it's brief about any two kinds or two of the solid break. You're asking about uh, any any two. Okay. So any two solid breakdown they might be asking, followed by the intrinsic breakdown. Intrinsic breakdown they might be asking. So intrinsic breakdown. Electrochemical, the very important thing is tree tracking concept followed by a thermal breakdown concept. So this is important thing. Okay, so we can just go through the slide. So still there are one topic in this unit, composite breakdown. So after that, I've already told you about the derivation. So that derivation will. So with that, this unit will be just so we'll be trying to complete this unit very fast, but this unit will be entirely full of theory, so it will be easy for you to understand and prepare yourself. So yeah, so regarding the internal marks, I have corrected for a few. So for other students, I will be correcting soon. Soon. And I'll be updating over there. And regarding the assignments, what you can see is that the will be assignment marks will be given to those who are uh, completing the assignment on time. So if they are submitting after time also, so the mark will not be provided. So if I am giving any kind of assignments means just try to finish it. So because these assignment marks will be definitely will be reflecting in your what you can say internal marks.